Good morning, good afternoon, and good evening. My name is Riyad Carey. I am the Global Blockchain Business Council's Senior Policy Analyst. It is my pleasure to welcome you to the GBBC's Virtual Member Forum, a bi-weekly webinar showcasing the innovative work of our members around the world. Today we are joined by Doug Johnson-Poensgen, founder and CEO of Circulor, for a presentation on how Circulor is empowering better business through supply chain traceability, as well as their success in the EV battery industry and their solution for plastics recycling and green steel. Before we begin, I would like to briefly introduce Doug. Doug has 25 years international experience as an executive and non-executive director operating in TMT, financial services, IT, and management consultancy sectors. His leadership experience spans roles in large corporates, including Barclays, BT, and Serco, scale-ups like Cadence and ISD, and startups including Circulor and Snapdragon. He has broad functional experience with consistent themes being innovation, both new product and to drive transformation, delivering growth and regulation. We welcome your questions at any point during Doug's presentation and the webinar, so please submit them in the Q&A tab at the bottom of your Zoom screen, and we will take them after the presentation. Thank you, Doug, for joining us, and I will now hand things over to you.
Thanks very much, and echo that. Good morning, good afternoon, good evening, wherever you are in the world. And I'm very grateful for the opportunity to speak to you today on Global Earth Day. Some of you will have seen the news this morning that President Biden has committed the US to a 50% reduction in greenhouse gas emissions, which is quite topical given what I'm going to be talking about for the next 30 minutes or so. As I said, I'm happy to take interruptions as I go, or alternatively, we'll leave some time at the end for some Q&A if that comes from the group that we have here. And I'm grateful for you making time to join in. What I want to cover is a sort of very brief introduction to who I am and who we are as a company. I talk a little bit more about the nature of the problem we're solving. I've kind of given you a clue already by my introduction around Global Earth Day. Then I want to talk about a particular case study. This is a customer we've been working with for a few years now, Volvo Cars, and their electric vehicle battery supply chain, and unpack that and explain how the technology comes together to support them in their objective to be able to be more sustainable. Talk a little bit about what our plans for the future are, and then open it up for questions. As I said, I welcome interruptions as we're going. Sorry, let me turn my phone off. I welcome introductions as we go in order to get a conversation going with all of you. So first off, then, us as a business, we are about 4 years old. We've been around, founded in the UK, now have offices across Europe, just about to open an office in the United States, already have an entity there. And our business is to support manufacturers and companies to prove and improve their ESG performance. And ESG, as I'm sure many of you know, means environmental, social, and governance. And that covers everything from environmental damage, including greenhouse gas emissions, as well as human rights. Many supply chains, for example, have concerns about forced labor or child labor within them. That's where the social side of this comes into, and governance obviously is relevant also to the way in which companies are run. And the reason I've said prove and improve is that fundamentally you have to be able to measure something if you're going to be able to try and improve on it. And I'll unpack that properly as we get into the case study. But before I do, I just sort of talk a little bit about the nature of the sorts of problems that we're grappling with, and I'll turn this off in a second if it gives anybody a headache, because this if it plays too much on your screen, it becomes can play tricks with your eyes. But the supply chains that produce the products that we as consumers like, whether they are our mobile phones or our laptops, or the EVs that we now, many of us aspire to own, or the cosmetics that we put on our face, or the soap that we use in our bathrooms, all of those supply chains come with significant challenges. So if we talk about soap, palm oil, for example, is a major cause of deforestation, as is beef. That's one reason why consumers of leather, whether that's car manufacturers or fashion brands, increasingly concerned about traceability of leather. Or I mentioned electric vehicles. What most people don't realize, we believe that electric vehicles are better for the planet, but the environmental cost of creating them is absolutely enormous, with half of the total supply chain's contribution being the battery itself. And many of those raw materials come with significant concerns around either human rights or environmental damage. Some of you may know, for example, that lithium-ion batteries contain materials, obviously lithium, which is a cause of concern for water use in places like the Atacama Desert. Cobalt is associated with child labor in the Congo. 60% of the world's cobalt is mined in the Congo, or nickel mines in Indonesia that are putting tailings into the deep ocean and causing irreparable environmental damage. And the image on the bottom right here is actually an aerial image of a tailings dam collapse. Mine tailings, i.e. the stuff that's dug out of the ground that isn't wanted, have been piled up into things like dams for generations. And it's a significant unintended consequence of mining operations globally. The number of tailings dams collapses that have caused huge deaths in all sorts of parts of the world is a significant concern. And you add, of course, you can see plastic in oceans there. The reason we have plastic in oceans is a consequence not only of an excessive use of single-use plastics, but also the poor management of waste on land. Traceability plays a part in solving all of these. Where has my palm oil come from? Is my used cooking oil really used cooking oil? Has my cobalt come with, from somewhere that mines responsibly and treats its workers fairly? Is the cement that I am using for construction coming from somewhere that uses carbon capture technology in the production of the cement? Cement is one of the largest CO2 emitters in its manufacturing process. And these are the sorts of challenges that brands like car manufacturers are starting to really get to grips with. We as consumers are still largely ignorant of the things that go on, to create the products that we want. I mentioned cosmetics earlier. Cosmetics not only contain palm oil, but also mica, which is what creates the shimmer. Mica is also used in other uses like heat insulation within electric vehicle batteries. Much of the world's mica comes from places like India and Madagascar, which have concerns around child labor. So I think I've labored enough about the problem, the nature of the problems that greater transparency can potentially help solve. So who are we working with? I said we're a relatively young company. We were a pioneer in traceability, particularly in the battery supply chain, the EV battery supply chain. And our customers, these are just the public ones. Our customers range from Volvo Cars, Polestar, you can see Daimler or Mercedes-Benz on there, Jaguar Land Rover, Total, oil major, also an investor of ours. And a whole plethora of suppliers in the midstream, primarily in China, because the majority of supply chains that produce the things that we consume, and particularly when it comes to things like batteries and rare earth elements used in the drivetrains of electric vehicles, go through China. You can see a selection of our investors there. We're closing another investment round later on this week. So in fact, tomorrow. That is the end of this week, so that list will grow a little bit. We're very proud to be associated with GBBC, and I'm grateful for the opportunity that Sandra and others have given us in order to speak today. The experience that I'm drawing on ranges now from quite a number of years of experience of working alongside these sorts of participants in order to try and gain greater transparency into their supply chains, and with it improve their performance. And that's really what I'm going to talk about in my case study. I'm going to do a deep dive into the most mature of those with Volvo Cars. So, we all know Volvo. It's a brand that has always been associated with safety, and their adverts from the 1950s always showed a child in the back of the car, kept safe, in a dangerous situation or in a crash. Volvo was actually the inventor of the seatbelt that we've all come to know and love in vehicles, and they open sourced that innovation because they believed that safety was not, not something that they should hold back. And share. And what they're trying to do now is extend that brand promise of safety for the next generation to sustainability. If you look at Volvo's ads running literally now, you will see a child in the back of the car, windmills in the distance, and a conversation about their obligation to do business responsibly and sustainably. And part of that means not only running your own operations, your own manufacturing facilities in a more sustainable way, but also making sure that the products that they buy, that they combine and assemble into vehicles, have been responsibly sourced, that the risks within their supply chains are properly managed, and increasingly that they understand the embedded carbon within those products. Let's just unpack embedded carbon a little bit, and then I'll go into a bit more of a discussion of technology. If you mine ore in a mine site in the Congo and you move that material by ship to China, where it undergoes, refining, which involves the investment of a considerable amount of energy, and then you amalgamate it with other materials in order to create cathode material, which is then, an ingredient in manufacturing a battery cell. Lots of battery cells become a battery module. You end up with something that has consumed a significant amount of not only natural resource, but also energy in its production. An electric vehicle battery accounts for half of the total supply chain's contribution to the manufacture of a car. And the supply chain's contribution as a whole is about 70% of the total. So, we all assume that buying an electric vehicle is good for the planet. Today, it isn't. Today, it has a huge environmental cost. And that's why grappling with what is going on in the supply chain is a fundamental challenge for car manufacturers. You can see a quote here from the Chief Procurement Officer, just recently left that role, talking about us and using us as a proof point to demonstrate that they were serious about this. So here's their description of how they use blockchain in order to help them, and then we'll unpack that and describe it in a little bit more detail. Whoops. That should be a video playing. Hold on a second. I don't know why my sound isn't working. Bear with me a second.
Implementing traceability of cobalt used in our battery and car production by applying blockchain technology. A blockchain is a digital ledger containing a list of records linked to each other via cryptography. Within supply chains, the technology creates records of transactions which cannot be changed, while also enforcing a common set of rules for what data can be recorded. This allows participants to verify and audit transactions independently. The blockchain, in conjunction with inspection on mine sites, GPS tracking, entry and exit scanning, verified logistics providers, facial recognition, ID checks, and time tracking, all contribute to a material's traceability from the mine to the car factory. We are committed to full traceability, so our customers can drive electrified Volvo cars knowing the materials have been sourced responsibly.
So, bear with me a second. So that's Volvo's own video. Love the Swedish accent. That's Volvo's own video describing how they're using blockchain to help them. And it's not just blockchain, and that's what I'm going to try and explain. But first of all, I want to make you all experts in battery production very briefly without going too nerdy. I mentioned that material is dug out of a mine site, and then it goes through smelting and refining and amalgamation with other materials before it's those materials are incorporated in a battery cell, becomes a battery module that goes into a car. And you can see that represented through those circles at the top of this diagram. That journey from mine site via multiple steps to the point of the car. And to give you some sense of geography, you're talking about mine sites in places like Africa, but also, for example, nickel produced in Australia. going to refineries in China. Those refineries in China will then ship the product of what they do probably to a cathode manufacturer in South Korea, who will ship back the material to a battery manufacturer that might be in another part of China that will manufacture the battery modules that will then be shipped to an assembly plant, some in China, some in Europe, some in North America, at which point the battery module is put into the vehicle itself. So not only is that an awful lot of crisscrossing around the globe, which clearly comes with a significant sort of carbon cost, but also those individual processes are very, very energy intensive. That's why the battery contributes such a large amount to the embedded carbon within the car. And there are broadly two complexities here. The first complexity is that, particularly when you're talking about material that is mined in operations in, for example, the Congo, where you're concerned about responsible sourcing, how can I be confident that the material that I'm tracking has actually come from where it is claimed? And the challenge with every technology platform is, crap in, crap out. We all know that, and therefore that first digitization of the commodity is the first significant challenge, particularly when you're talking about artisanal production in somewhere like the Congo. And the second broad challenge is, given that this material changes on its journey through the supply chain, it's not like a tuna steak, which is just a subset of the bigger tuna that came out of the sea. Here, the material undergoes fundamental chemical transformations, amalgamated with other things, etc., etc. You have to be able to, at each of those circles here, except for the transport components, be able to connect the input ingredients to the output product of that process reliably. Now, I'm going to pick each of those two in turn and unpack them a little bit, just so that we can understand some of the technology challenges. So to reliably record, a commodity from its source, you have to be able to create a sort of a digital representation or a digital twin of that commodity in order that you can then follow it on its journey. Now, imagine for a second you are standing in a muddy puddle in a mine site, a managed artisanal site in the Congo. There is no technology there, probably not even a mobile signal, but you have to be able to create a digital twin for a 30-kilo sack of stuff, or possibly a 1-ton tote, depends on the mine site. Now, in order to do that, we collect a number of pieces of data that we fuse. Now, some of the larger managed artisanal sites, we've actually put in place a local network together with processing on the ground, essentially doing things on the edge and only taking the minimum amount of data from that mine site and passing it to the cloud, because of course network coverage is poor and data is expensive, particularly if you're talking about some places like the DRC. So the combination of the identity of the individuals involved, their location, as well as the composition of the material and its weight, combine together with a unique identity, which could be a tag with the QR code on it, or it could be any form of appropriate labeling. And we'll talk about counterfeiting in a second. And together, those bits of data, together with the tag, create the identity for a blob of material. Now, I mentioned facial recognition. It was also mentioned in the Volvo video that you saw just now. We use facial recognition in order to record that known counterparties are recording data for the first time, and that a known counterparty is bringing material to a collection point. And that is to overcome concerns around just merely buying material in the local markets. The location will come from the mobile device, which we provide to these sites. But of course, GPS spoofing can be a real challenge, particularly with Android devices. It's as simple as downloading an application. So we've had to build a whole variety of defenses against GPS spoofing. And everything I'm describing here can be done both online and offline. The composition of the material is routinely captured by handheld mass spectrometers at mine sites, because you want to pay your miners for good dirt, not any old dirt. And so you can read the screen of that directly using OCR into the mobile application, or alternatively, very few of them have a Bluetooth enablement, and therefore that data comes across automatically. And although our platform is tag agnostic, we actually provide tags with attributes to mine sites, which means they can only be used by you at your mine site this week, which means that there's no black market for those tags. So even if someone had access to the platform, which is a private permission platform, and the mobile app, they wouldn't be able to use tags that they bought elsewhere. And the reason for that is to prevent a black market for tags, which means that people can pass off material as being responsibly sourced when in fact it hasn't been. And so that data combined, attached to a blob of material, which could be something as small as a 30-kilo sack, creates that digital twin for the ore, which can then go on its journey to the first of those processing steps, which might be a smelter. And the basic discipline is simply do not mix material that has a tag with material that does not have a tag, so that material of known provenance isn't mixed with material of unknown provenance. Although the platform can cope with that commingling, it makes sense, particularly in high-risk locations like the Congo, not to do it, particularly when a car manufacturer like Volvo insists that it has no cobalt in its supply chain that doesn't come with provenance. And increasingly, it's not just Volvo, increasingly car manufacturers want to be absolutely certain that there's no child labor in their supply chain, which means they want provenance. Now, that's the first bit of it. The second one is how do you connect the input to the output at a particular step, like a smelter or a refiner. And I often liken this to a cake recipe. We all know that if you take a certain amount of flour and some eggs and some sugar and you mix them together in a known quantity defined by a recipe and then stick it in the oven for an hour, you get a cake. Well, it's very similar to what happens in a smelter. You take raw material, you add other things to it, you put it through a defined process, it spends some time potentially being heated, and what comes out of the other end is completely different to the input ingredients, but you know that it has been made from those input ingredients, even though now the product, which different weight, different chemical composition, as provided that you're able to prove elapsed time and you're able to prove mass balance and you haven't mixed materials or commingled materials, then you can prove that this product has come from these ingredients. So think cake recipe multiple times through this supply chain. Now, from a technology perspective, we use, obviously there's a distributed ledger in here, we use Hyperledger Fabric for that. Its principal purpose is notarization in this case. We also use Oracle databases. All the data comes into Oracle databases first, which is where the business logic and business rules that define how, for example, a cake recipe is coded sit. And then a subset of that data is put onto the distributed ledger. And obviously, when you're doing things like facial recognition and other things at the edge, that's an application of AI in the mobile application in the mine site. And then if you look at the sort of the bottom half of this screen, you can see an articulation of what is going on in order to create, that chain of custody through the supply chain. Now, the interesting bit, and I started this conversation talking about Global Earth Day, and I was talking also about the importance of greenhouse gas emissions reduction in the supply chain. And yet everything I've just talked to you about is how to create a reliable chain of custody for those materials from source to consumption. When you know which actor in the supply chain has handled what volume of material at any point of that supply chain, you can attach additional information, ESG metrics, whether it's greenhouse gas emissions, scope 1 and 2 emissions, working conditions, whatever they happen to be that is of interest to you, you can attach those to a step in the journey, to a facility, or to a transport operator on this supply chain. And depending on how much of the material goes through each of the actors over time within the supply chain, you can calculate, for example, the total embedded carbon in an individual battery. Now, you might be listening to me and go, why on earth would anybody go to all of that effort? The answer is because increasingly regulation is going to require it. So just before Christmas, the European Commission published the latest iteration of the EU battery regulations, which will require car manufacturers to be able to demonstrate the embedded carbon per battery, because it's such a polluting thing. And at the end of the first life of the battery within the vehicle, to make a conscious decision about whether or not recycling it or reusing that battery in a second life, like an energy storage system, is the sensible thing to do, based on the amount of embedded carbon that's already in that battery versus the amount of additional energy that's going to be invested in it if you were to recycle it. A battery from an electric vehicle is most efficiently and most sustainably reused in a second life application rather than being recycled. most of us assume that recycling is good, but not necessarily if what it does is further increase the amount of energy and carbon generated in the use of this battery, which rather defeats the object of us all buying electric vehicles. We expect much of what the European Union has done under what's called the Green Deal to rapidly cross the Atlantic to North America under a Biden presidency. And today's announcement by President Biden around a 50% reduction by 2025 in the US is a very clear signal that the sorts of things I'm talking about here have got to be grappled, and probably will now be grappled at scale and speed by global supply chains, because as we as consumers buy things, that will have an impact on these sorts of supply chains. So that's a brief introduction to how provenance plus additional attributes of data along the supply chain can allow a car manufacturer like Volvo Cars in order to see what's going on in their supply chain. Now, the reason they're doing it is because when you can measure something, you can start to manage it. And in this case, of course, they're the purchaser of electric vehicle batteries. And when you have data about, how, for example, your EV battery over time has a higher or lower carbon footprint, you can use that intelligence as a way of engaging your supply chain in a conversation around how, price and sustainability needs to be balanced to make smarter procurement decisions to reduce your overall carbon footprint. And that leads us to some example dashboards. On the left-hand side here of this slide, you can see a selection of dashboards that show the flow of materials. You can see a Sankey chart there that shows how different volumes of material over time go through different participants through the supply chain. Supply chains obviously are not linear. And a world map, and at the bottom of this, a selection of data around things like anomalies within the supply chain, where, for example, there are errors in the cake recipe, or something appears to have been introduced from a third-party source. And in the bottom center here is a graph that shows the embedded carbon, or a proxy of the embedded carbon in batteries month on month for a car manufacturer. Now, this is dummy data, but the message that I'm going to give is actually based on a project we did last year with Daimler, where we showed just this. And if you look at the first month versus the last month, the blue and yellow bars represent renewable and non-renewable energy invested by the supply chain in the manufacture of the green bars worth of batteries. And if you look at the first month, you can see quite a large number of batteries, and something like a quarter of the total energy, effectively carbon, invested in manufacturing those batteries. Compare it to the last month, less batteries, 4 times as much energy. Now, when you get that kind of data about what's going on in your supply chain, and you can drill into this and see which participants in the supply chain are making the most significant contribution to the carbon footprint of your batteries, you can use that intelligence in order to start to buy smarter, to specify which participants in the supply chains you're willing to contribute to the batteries that you buy, and buying smarter, we believe, for a car manufacturer like Volvo can potentially reduce by about 50% the total embedded carbon in the battery. That's a material prize. There are only 12 raw materials in the battery, and although what I've just described to you is complex, it's nothing like as complex as trying to track the other 20,000 components that find their way into a vehicle. So, this is the sort of visibility into a supply chain that has never previously existed. And the reason why a distributed ledger plays an important role in these supply chains, and I know I'm talking to the choir, preaching to the choir here, is that you obviously have an enormous asymmetry between, upstream small producers potentially of raw materials, and downstream, huge original equipment manufacturers. And there is no central authority that could somehow collect and manage all of this data. And so through a combination of business rules applied equally, and the fact that data is essentially stored in an immutable record, there's no ability to rewrite history if it subsequently proves to be inconvenient. The amount of time between, ore at a mine site and car might be 6 months. And clearly the upstream producer has no idea where their mined material is going to end up. And so that's why data is collected in real time. It's encrypted and only selectively decrypted for the bits of the supply chain when, you know, someone purchases something or it eventually finds its way into a vehicle at the other end of the supply chain. Now, I've been talking here about electric vehicle batteries, and for us, that is a major focus because, as I mentioned, you know, we all want to move towards greater electrification of transport, but that comes at a significant environmental cost, which needs to be addressed through these sorts of solutions. But beyond this, you know, as a business, we are starting to look at how you know, other big manufacturing industries like aerospace have to grapple with very, very similar challenges. Obviously, manufacturing an airplane comes with a significant resource requirement and the same sorts of supply chain complexity challenges that we've just been talking about. And aerospace, you know, like, you know, Boeing and Airbus absolutely recognize that they face exactly the same challenges as car manufacturers, albeit on a different, you know, time scale, given that, you know, aircraft have a life scale of about 50 years from design through build through in life, whereas of course most cars you might measure as a decade. And beyond that, you know, we've been talking about complex industrial supply chains where materials change on their journey. A particular focus for us is in plastic waste, the chemical recycling of plastic waste specifically. Today, the majority of recycling of plastic is what's called mechanical recycling, which means the plastic is broken down and turned back into pellets of the monomers and polymers. And the challenge there is that there are a limited number of uses of that second life plastic post mechanical recycling. You can't take food grade waste and mix it with bleach bottles and get plastic out the other end that you can use for much other than construction. But if you are able to take that plastic waste and turn it into pyrolysis oil, hence chemical recycling, and then send it back to the same oil refineries that originally distilled the crude oil to make, you know, monomers and polymers that are manufactured into Coke bottles and other things, then you have the ability to reuse plastic potentially indefinitely as many times as you want. There are economic challenges to making chemical recycling of plastic waste work because global plastic supply chain is optimized for the first efficient and only use of plastic, with the exception of things like high value engineering plastics, potentially those used in car interiors. But, you know, the challenge of being able to recover plastic, make sure that it's been responsibly collected, particularly in the third world, and being able to demonstrate a certain proportion of recycled content, which certainly in Europe, we are introducing plastic taxes to require a certain level of recycled content. You have to be able to prove it. And to prove it, you need traceability. What I've just described to you happening in car batteries, we're doing right now with Total in a project in the chemical recycling of plastic waste, taking domestic waste through sorting to pyrolysis oil plants, to oil refineries, and back into plastic and back into consumer products. And you know, once the plastic supply chain actors work out how the economics of a circular economy for plastics will work, then traceability will be an important part of it. Beyond that, and I've touched a little bit on circular economy business models, whether it is the recycling of batteries or the recycling of plastic, but there are many industries looking at circular economy business models, including, you know, ones that perhaps you might think might not do. I mean, one of the oil majors is looking at lubricants as a service, the idea that it might lease lubricant to its customers rather than sell it and subsequently recover re-refined oil. And put it back into their supply chain. And there are mining companies that are looking at leasing battery materials to the battery supply chain. And there are all sorts of examples of people experimenting with circular economy business models. If you're going to lease anything to a supply chain or to actors or consumers, you need to know where it is and what its state of health is. And again, all of that requires traceability. So much of this presentation has been focused on the primary supply of raw materials to their first use, for example, in an electric vehicle. But actually, when you look at circular economy, traceability plays an important part in that too. Fundamentally, data is an important enabler of the circular economy as well as carbon reduction. With that, thank you for your attention. I hope that's been interesting and I look forward to your questions. And if you don't want to pipe up and ask a question now, then please ping me an email. You can see my email address here. I'd be delighted to engage in a conversation. Thank you all for your time.
Thanks, Doug. That was a great presentation. We have a couple questions from folks in the audience. First one is there any issue with getting buy-in from miners on the ground? And is there any incentive for them to participate in the tracking?
Yeah, so I mean, it depends is the answer. So if you take a supply chain like cobalt, there are bag and tag schemes and traceability schemes. You know, first generation paper-based schemes have been around for some time, and you simply can't sell your material legitimately if you aren't able to demonstrate where it's come from and that you've done it responsibly. Think of Blood Diamond. Many of you might have seen the film Blood Diamond with Leonardo DiCaprio. Same idea of an attempt to try and regularize mining activity. So the incentive is the route to market. Where there are, I mean, in the Congo, they're just in the process of introducing a scheme where Trafigura, one of the world's largest commodity traders, is going to implement managed artisanal mining and provide training and personal protective equipment and remove overburden so people aren't digging in deep shafts, as well as a guaranteed route to market. So there's a whole pile of commercial incentives being created for actors who act responsibly within those managed artisanal sites. But that doesn't apply across every supply chain yet.
Let's see. You touched on this a bit, but would you say that changes in this industry are being driven by consumers, retailers, or government?
A bit of all of them. So we as consumers, all of us as consumers, are starting to learn that the choices we make about the products we buy have a consequence. And if you pick up, for example, the Washington Post, you'll often see articles about challenges of, for example, child labor in supply chains. But there are many publications and news outlets that are starting to shine a light on these sorts of things, which means consumers do care about sustainability and human rights and potentially doing good for the planet. The other driver of change is institutional capital. Larry Fink, who's the chief executive of BlackRock, has been vociferous about improving reporting around ESG performance. He's called bullshit on a lot of the stuff that currently ends up in corporate reports, and is trying to ensure that their money goes to those people who are behaving themselves. And then the third driver of change is regulation. I mentioned the EU battery regulations and plastic taxes in Europe. What regulation does is improve the lowest common denominator. What it doesn't do is deal with those who really want to distinguish themselves by being much better than the minimum acceptable standard.
Yeah. Two sort of related questions. When will consumers be able to recognize more transparency in the supply chains related to items they use daily?
Yeah.
And what is the best thing consumers can do to push for this change?
Yeah, good point. Well, what can consumers do? At the moment, most brands don't really report very much about their ethical behavior. Increasingly, and I've mentioned Volvo in this case study I was talking about, some brands are actively trying to put forward their credentials and compare themselves with their competitors in order to give consumers a choice that might be more sustainable. And so, what can we as consumers do? Continue to consider these things interesting and potentially drive our buying decisions. I'll give you an example, and I've mentioned them a few times because that's the case study I was talking about. Volvo Cars last year saw its sales increase when most car manufacturers saw their sales decrease. And one of the reasons for that, they think, is because they're making such a push into being demonstrably more sustainable.
Interesting. Here's a sort of different question. It says it's great you can measure ESG metrics better for greater transparency, but are there global standards for apples to apples comparison?
Yeah, that's what Larry Fink at BlackRock complains about. At the moment, there are so many standards and so many different methods for measuring stuff, like, for example, scope 1 and 2 emissions or calculating your scope 3 emissions. You can pick whichever method might make you look best. Now, a cynic would suggest that at the moment we're in the early days of ESG, and therefore, people are creating pretty brochures and telling good stories. But the reality is that I'll believe a brand when they say it's difficult, and here's where we're doing well, and here's where we're not doing well, and this is what we're going to do about it. But right now, there are any number of different ways of measuring your carbon emissions or other metrics, and that lack of consistency is part of the challenge.
Yeah. Let's see. I think you touched on this, but do you verify that child labor isn't involved with the miners?
Yeah, so I mean, obviously no technology can completely replace due diligence at a mine site. But and in the example that I used of the managed artisanal sites that Trafigura is establishing, you've actually got a whole soup of non-governmental organizations and auditors and other people involved in making sure that working practices are appropriate. Our job is the traceability from those responsible sites then through the supply chain. But and forgive me if I overstated this, a technology will not solve all of these problems on its own. What it does do is provide a surveillance overlay over a supply chain that makes it much, much harder for people to not be transparent.
Yeah. Let's see, we have one final question here. If you're in communication with other electric vehicle manufacturers, they specifically ask about Tesla. But
if I didn't put the logo on there, I can't name them. We are working with a whole variety of electric vehicle manufacturers, including North America. But whoever asked the question, please ping me an email, and I'd be interested in talking to you.
Okay, perfect. Well, I think that does it for questions. So thank you for joining, Doug, and for your presentation and taking the time to answer our questions.
Pleasure.
Thank you also to everyone who joined the webinar. We will share a recording of this presentation and post it to our YouTube channel, as well as share links to learn more about Circulor and get in touch.